Welcome to myprojectbazaar.com. Project title: Enhancing Energy Efficiency of Wireless Sensor Network through the Design of Energy Efficient Routing Protocol. Now we are going to see the abstract of our project. Wireless sensor technology is playing a vital role in many of the commercialized industrial automation processes and various other real-life applications. It is particularly suitable for harsh environment applications where deploying of other network infrastructure is difficult or almost impossible, such as in battlefield, hazardous chemical plant, and in high thermal environment. It is not uncommon to see that most of the crucial surveillance and security applications also rely on sensor-based applications. A wireless sensor networks or spatially distributed autonomous sensors to monitor physical or environmental conditions such as temperature, sound, pressure, etc. and to cooperatively pass their data through the network to a main location. Wireless sensor network technically and economically feasible to be widely used in both military and civilian applications. Generally, energy efficiency in these networks is a main concern for the cross-layer design methodology. Hence, the proposed system uses a different network structure for clustering process. Clustering is done for the group of sensor nodes which are deployed in the network. This clustering is performed in layer architecture. That is, the network is created by randomly distributed the sensor nodes with a static sink, and these sensor nodes are divided into clusters with the cluster head in different layers. Finally, the simulation results shows that the proposed network topology is very efficient for transferring the data. Let's see the flow of our project. First, the network model is implemented, that is, the number of sensor nodes and the sink are created in the network. Then, the cluster division process is executed. This cluster division process is done by the layer architecture. That is, the network is separated into layers which are considered as the clusters. After that, the cluster head election is processed. For each cluster in the network, a cluster head is elected. After that, PRRP routing is executed. In this PRRP routing, the route is established between the nodes and the base stations. If the route is established means it allocates the time slot for the nodes to transmit packets, because all nodes can transmit packet at the same time. So if the route is not established means it waits in the queue until a channel is allocated for the packet transmission. After the time slot is allocated, packet transmission is processed. Finally, the performance is analyzed. In this, the existing is compared with the proposed system. Let's see the output demo. First, open the terminal window. Then go to the directory where we have the code. Then type ns space file name .tcl. Here our file name is main, and for running the program, this is the main command. Give enter. Now the nodes are created in the network and the position and energy are all updated. After it's completed, we can see the output in network animator window. These are all printed here according to the PRRP routing process. Now the simulation is end. Network animator window opens. To see the output, go to this window. These are all the nodes that created in the network within the transmission area. To run the simulation, click on the play button. Now this is the base station that is sync. The simulation is running now. We can speed up the simulation process. Now the clusters are created in the network according to the layered architecture. Layer 1 is created, layer 2 is created, now layer 3 is created, and finally this is the layer 4. So each layers are considered as the clusters, and for these layers a cluster head is selected. So for each cluster a cluster head is selected and it starts communication. Now here a sensor node transfers data to the cluster head, nearby cluster head, and this cluster head finally transmits data to the base station. So for this it have to be find out the route to transmit the packet, so that is done by the PRRP routing. Now this class packets are transferred to the nearby cluster head. Like this the packet is going on and reach the base station. To see the result we can we can able to see the in graph only. So give GNU plot graph name dot plot. So this is the delay graph in which the number of nodes are varied and the delay is calculated. So this is compared for the reach and CRP and PRP. Our PRRP protocol have less delay compared to the other existing protocols. To see the another graph, type GNU plot graph2 dot plot. So this is the throughput graph in which the proposed system PRRP achieves a high throughput than the existing reach and CELRP. So this throughput is calculated by varying the simulation time. At unit time, how many maximum packets are delivered is calculated here. So we conclude that the proposed system is achieves a high performance than the other existing system. That's all. The demo is completed. Thank you for watching this video.